Assalamualaikum warahmatullahi wabarakatuh and good morning to Dr. Ais Hanizam bin Madun. It's an honor for us, Group 3 Section 1, to stand in front of you to deliver our practical work presentation. This group consists of Vishnu Majendran as a leader, Datu Suhari bin Awam, Sharvika Pasubati, Muhammad Hafizuddin and Nur Hanizawani binti Muhammad Azlan.
First, we'll start from Lab 1, which is multimeter. So, in this lab, we explore the Ohm's law and how we use multimeter to measure electrical properties. And for the objective, we measure resistance and voltage with the multimeter and apply Ohm's law to predict values, determine power current for appliances in our biodiesel pilot plant. For the observation, we have measured various components. The AA battery shows low resistance, consistent with its internal resistance. Resistors displayed high resistance as expected. The plug socket showed no resistance, indicating a direct conductor. So, as a result, the battery showed an average resistance of 1.723 ohms with a voltage of 1.199 volts. Resistor 1 and 2 had high resistance of 246.93 ohms and 241.3 ohms respectively. The plug had no resistance and a voltage of 39.2 volt. So for the discussion, the battery low resistance aligned with its internal resistance. The resistor's high resistance confirms that they are low regulating current. The plug's zero resistance indicating that it's a direct conductor, and its voltage suggests that a connection to a higher voltage source. So, as a conclusion, the multimeter is a crucial tool for analyzing electrical properties. Our measurements demonstrate its utility in assessing component functionality and ensuring proper circuit performance. So next, we'll be moving on to the Lab 2, lighting. Now, for the lighting, we have explored the efficiency of lighting equipment at UTHM Biodiesel Pilot Plant, and our objective is to identify and list the type of lighting equipment used, analyze the electrical energy costs associated with the operating the light for 8 hours, understanding the efficiency of lamp usage. We found that the plant uses a variety of bulbs, including SON E40, T5, and T8 fluorescent lamps. Always used SON E40 downstairs and T5 upstairs, while labs and classrooms had higher counts of T8 lamps. So as a result, the total daily cost for lighting was Rm23.67. The lighting system efficiency was evaluated with 18 bulbs achieving 88% of efficiency, while SON E40 bulb had the highest reported efficiency of 95%. The overall system efficiency was 87%, indicating potential for optimization, especially in older fixtures. For the discussion, the experiment highlighted the importance of energy efficient lighting in industrial environments. So in conclusion, to improve energy efficiency, we recommend replacing fluorescent lamp with LEDs, installing motion sensors, upgrading electronic ballast, and maintaining lighting fixtures, implementing day lighting strategies, monitoring energy usage, and exploring tariff and incentive will also help. That's all.
Next, for our third lab, which is the aircon. In this lab, we analyze the energy consumption of air conditioning units in the biodiesel UTHM. So the objective is to identify the types and the quantities that air conditioner use. Also to analyze the electrical energy cost and consumptions during an 8-hour daytime shift, and it also our objective also to determine the EER, which is the energy efficiency ratio for the different types of the air conditioners. In our observation, there's 3 types of air conditioning system, which is we have ceiling mount, we have cassette type, and we have ductless air conditioning. in each room have a specific occupant limit. So here we have surau, which is the total area is 89.12 square feet, but the maximum capacity only limit to 5 people. This restriction due to the space being divided two functional areas, which is the 1/3 and the 2/3 for prayers. The 1/3 is for the ablution. As a result discussion, the total energy cost for operating all of these conditioners is Rm 155 ringgit 60 cents during the 8-hour daytime. As a conclusion, we can conclude that this lab experiment achieved the objective, which is the assessing the energy cost that associate with the air conditioning operation, and the analyzing about the heat generated by each unit, and also the determination of the EER for different air conditioning in the biodiesel Utasham. Next, for cooling tower. So as an introduction, this lab analyzed the cooling tower system at the biodiesel Utasham. So the objective to list out and identify the types of cooling tower available and understand the operation and the performance. As an observation, the cooling tower was not operation due to the technical issue, and we examine the types and quantity of heat exchanger, which is relate to the efficiency and the performance of the cooling tower. So for the result in the discussion, we have that the discharge pump was the most energy intensive components that are accounting for the majority of the operational costs, and the efficiency that we calculated, we get the 76.6%. So as we can conclude that these findings highlight the potential for cost saving and performance and improve through the measures such as maintenance. Additionally, we have the renewable energy sources that could further enhance for sustainability.
Next part, which is air compressor. Air compressor compress and pressure air convert to power into kinetic energy. They can operate on hot condition and can power equipment and tool. Positive displacement compress like rotary vents and reception compress a command process control system managed by the cell plant, including valve actuator for controlling temperature, flow rate, pressure, and level difference. For objectives in left part, we identify and list the type of the compressor in the biodiesel plant and the market. Second, we analyzed all the electrical energy costs to operate the biodiesel plant. And third, we determine the efficiency of a compressor in biodiesel plant. For in the observation, the air compressor test at the biodiesel demonstrate reliable operation, peak efficiency, consistent temperature control, noise system. It will depend performance. So on this discussion, we analysts focus on the performance and energy consumption. Um, so to improve efficiency, regular maintenance, energy recovery, optimize schedule, we need to upgrade to energy efficiency model can be implemented. This could be significant to improve the air compressor operation efficiency and cost effectiveness for the biodiesel production process. So as you can see the result, we define that the efficiency air compressor efficient is 13.31%. So that's how we calculate. We You can find you can see the previous slide. For the conclusion, the utilization biodiesel pilot plant for efficiency is 30.31% efficiency. So that's all for the air compressor leg part.
Hello, Dr. Rice. I will explain about Lab 6, which is boiler. In boiler, biodiesel production is a suitable alternative to fossil fuel, with boiler playing a crucial role in converting raw material into high-quality fuel. Understanding boiler operation and efficiency is essential for optimizing energy use and ensuring high-quality biodiesel output, promoting sustainable industry process and efficient energy system. The objective of the Lab 6 boiler to identify the type of boiler used in the biodiesel plant, to understanding the different boiler types, operation and the performance, calculate the boiler efficiency, serve excited method. Then the study aimed to evaluate consumption of the feed water in fuel pump. So as can see, the discussion in the group, the data showed that boiler efficiency increased with higher operating pressure, leading to reduced energy loss and better station generation. Steam generation. Optimizing boiler pressure can lead to significant improvement in efficiency, concession and operational costs, but must balance in safety consideration. In observation, the fire tube at UTHM biodiesel plant uh, effective with potential for future improvement through modern monitoring automation system. As you can see in the calculation result, we identify that the efficiency is 82.125, which is we calculate in four type different category, which is pressure 8, pressure 6, pressure 4 and pressure 2. So as you can see in the result, this is how we solve the calculation efficiency in this slip boiler.
Alright, so moving on, we shall be talking about our next lab, which is Lab 7, which is regarding to chillers. So let me introduce a bit about chillers. So chillers are essentially known for heat ventilation and air conditioning systems and play a critical role as well in cooling fluids to regulate temperatures in various environments and also in the work principles. So utilizing such vapor compressions or absorption refrigerations, they are very efficient in removing heat, and they also make it ideal for applications in commercial buildings, industrial plants, data centers, as well as biodiesel production facilities like the one we have in UTHM. So these chillers usually maintain precise temperatures which are required for processes in the biodiesel production, such as transesterification, purification, separation, and ensuring quality and efficiency. Okay, so moving on to the objectives. The objectives of this lab would be to simply recognize and document the various types of chillers, as well as to evaluate the energy expenses occurred during the operation of the plant during an 8-hour daytime shift, and also to assess the performance of the efficiency of the chiller system. So next, moving on to our observation as well, we have noticed that our team has detailed the chiller's roles, technical specifications, whatnot, and such as the spec sheets as well into the practical. So during the startup as well, we noticed that the heat exchange fluid was circulated by the opening or in the system valves, and the control system was activated with adjustments to temperature and flow rate. And also critical parameters like the temperature, pressure, and the flow were monitored closely during this practical was going on. So up to our results, we will get the coefficient of performance for our chiller, which would be at a 82.05 percentile. And then the cost operation during the 8-hour day shift would be around 8 ringgit and 76 cents. Okay, so moving on to our discussion as well, we have noticed that the operation of the chiller has outed with an outstanding performance of 82.05%, which is quite impressive given of its age. But there are also procedures that we can ensure for optimal performance of such chillers, so we can reach the superior efficiency and possibly get a more quieter operation. How we can say, like a more quiet operation to go, because as we know, chillers also produce a lot of noise. So in conclusion, what we can see is that this experiment, we have successfully analyzed the efficiency and the operational cost of this chiller during a 8-hour day shift with an efficiency of 82.05% and a daily cost of 8 ringgit and 70 cents. This study offers valuable insights to this study and the next future studies for future students in the biodiesel plant, especially for this chiller. Thank you.
This is practical lab for electrical motor. This lab analyzes electric motor performance and energy used in a biodiesel pilot plant over an 8-hour shift. We aim to identify motor types, analyze electrical motor, and last but not least is calculate motor efficiency. By observation, 15 types of motor were found. Motor range from high power 11 kilowatt for cooling tower to low power is 0.37 kilowatt for dosing pump. For the result, average motor efficiency is 67.32% and total daily cost is 150 ringgit and 93 cents. For the discussion, efficiency can be improved with upgrading to efficiency motors using variable frequency drive and regular maintenance. For the conclusion, prioritize efficiency motor replacement using VFD for speed control, energy saving, and last but not least is implement regular maintenance for optimal performance and cost reduction. For the last practical lab is electrical appliance. This study assesses the energy efficiency for electrical appliance used in the UTHM biodiesel pilot plant. We aim to identify the area for improvement and propose the realistic solution to optimize energy consumption. The energy efficient lighting system, cooling tower efficiency, boiler and compressor, and last but not least, the electrical motors was observed. And for the discussion, we observe that we calculate the efficiency and cost daily. We got that the air conditioning system consumed the most energy, which is 153 ringgit per day. Then while lighting was the lowest cost and highest efficiency, which is 87%. And the air compressor has the lowest efficiency, which is 40%, lighting significant energy losses. Then for the conclusion, energy conservation is achievable through the mindful usage and efficient appliance.